Let's examine the quotient rule for differentiation. Quotient rule would typically be used when you're trying to find the derivative of a fraction of one function of x divided by another function of x. In my first example, I'm going to start it off with a very easy one where f is not a function of x, but it's actually just a constant, and so is g. What we have to do here to find the derivative of the fraction of the two is we want to take the derivative of the top and multiply by the original bottom. Then take the derivative of the bottom and multiply by the original top. Then we'll divide by the denominator function squared. All right, so let's write down all the givens here. F is 3, G is 8. Now we'll find the derivatives of both of those. They're just constant functions, so it's easy. They're both zeros. And now we want to find the derivative of 3/8. We know the answer should come out to 0. But let's see if the quotient rule method is in agreement with what we've done in the past. So f prime would be 0. That's this. Now we have to multiply by the original g, which is 8. That's this. We have to subtract g prime, which is this. And then multiply by the original f. Okay. To finish it off, we will divide by the original denominator squared. So as you can see, this comes out to 0 over 64, which is 0. And so, yeah, the quotient rule in this case was in agreement with what we thought it should be. Let's try the derivative of 1 over x. F can be 1 and g can be x. We'll get the necessary derivatives here, 0 and 1. Now we'll plug into their respective places. That's the basic form of the quotient rule. Plug in our f prime and then our g. And then we'll plug in g prime and f. And then g goes down here, no derivative there, just the original g. Okay, as you can see, we're going to get negative 1 over x squared, which actually is the correct derivative for 1 over x. All right, lastly, let's try one where quotient rule would really be appropriate here to use. It'd be tough to solve this in other methods, so let's let f be the numerator function, 6x squared, and as you can see, this time it is a function of x. G can be a function of x as well, 2 minus x. Let's get the derivatives here in advance before we plug it in. Okay, now we're ready to plug it in. So we got to put in f prime, 12x, times the original g, 2 minus x. Subtraction between the terms here. Then we need g prime times the original f. And then we have to divide by g squared. And that'll do it. You could simplify it, but it's not required.